Okay, and then we'll, like when we get into next week, I'll finish these things up a little bit more. That way, at least you have a good idea of kind of how these things go. And actually, these things right here, you're going to do a lot of sign charts on. So I'm going to show you. I'm going to start with probably, let's go all the way to this example 3, because there's a little bit more going on that problem. But the other two are going to be a little bit simpler than this one. This has just got a little bit more to look at. So one of the things I'm going to try to do on these problems is I'm going to show you how to do this algebraically, then I'm going to show you how to do it graphically. So 2 things. I want you to know how to do that both ways. Okay, so what we're doing is an inequality. So you're looking at where this algebraic expression is less than 0. One of the first things you always want to do is you always want one side of the inequality to be 0, kind of like you would on a quadratic equation. Okay, you have to have that. And then, did you guys note that 2.6 was all messed up? Was it upside down? And yeah. Okay, I had somebody run that off for me today, and I noticed that. So I guess we can deal with it, though. This one, I think, came out okay, didn't it? Okay, it was just like 4 pages. Okay, so on 2.7, you want one side to be 0, and then you find the zeros of the polynomial. So we want to do that. So you actually start by factoring. So on this example 3 on 2.7, you would factor out an x out of that. So you want to start by just taking an x out of that. So if you do that, you'd have x times x squared minus 2x minus 3 less than 0. Okay, make sure you have that 0. If it's not there in the original problem, you're going to make it so. Okay, now we can factor this trinomial. So you want to factor this as completely as you can. So you'd have x. Then it looks like you would have x and x. You would have 3 and 1. And you'd have a minus and a plus like that. Okay? So what are the zeros of that polynomial? In other words, what are the solutions of that equation? 0, 3, and -1, right? Okay? So you would end up having x equals 0, x equals 3, and x equals -1. Now what that is that's just going to tell you how to make up your sign chart. That's all that's going to do. Okay? So what we're going to do on this sign chart below here, put these in numerical order. We're going to put a -1 there, a 0 there, and a 3 there. And this is going to look a lot like what I did in the last section. And doing these sign charts is a real big deal in calculus. So it's good this section is really good for a student who's going on to Calc 1. Okay, so what we're going to do is we're going to do test points. Let's do the factored form. To me, it's easier to plug stuff in the factored form. So we're going to do test points. Let's take like -2 and plug it into the factored form. So you'd have -2, -2 minus 3, -2 plus 1. If you can do that in your head, do it in your head. Well, all you're going to have is you're going to have a negative times a negative times a negative, right? Okay, because what I'm looking on that is just that's a negative, that's negative, that's negative. So what do you have? You have a negative, okay? So what that's going to mean then is you have a negative. So just like in the last section, that means we're below the x-axis. Okay, it means the same thing. And we're going to do a graph on this to kind of help us figure this out. Okay, next thing we do is let's do a test point here. Well, we'd have to use a fraction. Let's use like -1/2. It doesn't matter. You don't have to crunch it out. You just got to know if the answer is negative or positive. So I'll go into what I highlighted in blue. So I'll have -1/2 times -1/2 minus 3 times -1/2 plus 1. Okay, well, just think about what you have. You have a negative there, times a negative there, times a what? Times a positive. So you have negative, negative, positive. That's all you care about. So negative times positive is positive. So that means you're above the x-axis. Okay, that's the idea. Okay, everybody with me there? Okay, let's move on here. Between 0 and 3, let's use a 1. Okay, if we plug that in, we would have 1 times 1 minus 3 times 1 plus 1. So what you have there is positive times negative times positive. That's back to a negative. Just means we're below the x-axis. Okay, so far every example I've done is alternated, but trust me, they don't always do that. Okay, don't fall for that. Then finally, the last one, you'd have 4. When you plug it in, you would have 4 times 4 minus 3 times 4 plus 1. That's a positive times a positive times a positive, which means you're above like that. Okay, so that's what we did. Now, that's exactly what I did on the last section. Now, if you go back to the original problem, we were looking at where that's negative, where it's less than 0. So where did it turn out to be negative? There and there. So that means the solution of this inequality is going to fall into intervals. I'm just going to draw, make a little number line. Okay, right here and right here is where the answer is. So what you would have is a parenthesis and then shade to the left. And then in here you'd have parentheses like that. You just got to write that interval in interval notation. So what are you going to say? For your solution, you're going to say negative infinity to negative 1, parenthesis, union, 0, comma 3. Okay, you're writing that in interval notation. So your solution on this is going to be, again, negative infinity to negative 1, union, 0 to 3 like that. Most of what I did there was factoring, and I did the sign chart. Set builder, you'd go like this. You would say set of x, then you would say x is less than negative 1, or, and then this part right here I find students don't know how to do a lot of times. You would say 0 is less than x, less than 3. That's how you show that a number is in the middle of 2. You say 0, x, 3 in that order like that. So that's the answer to the problem, okay? Does that make sense, what I did? Okay. Now, let's do this graphically, and I can tell you what the graph's going to look like. I mean, I'm not even going to put this in the graphing calculator, but you could put this in the graphing calculator and easily tell how it goes. Well, here's basically what happens on this problem. Okay, so when we factored this, we had x times x minus 3 times x plus 1. Okay, so what we're going to do is we're going to put those zeros on, and we'll see if what we remember about this, because we learned how to do this a little bit last week. Okay, so what we have is we have a 0 at 0. This exponent, we call that the multiplicity. You guys remember that? And if the multiplicity was odd, what did that say? It said it touched. Okay, then we had a 0 at 3. Okay, it also has a multiplicity that's odd, so you touch. And then x plus 1 gives you a 0 of negative 1. And then you again touch like that. Okay, now here's what you got to know. How does that's a third degree polynomial. How does it go? Either this or this, right? Even degree, what does that do? This or this, okay? So it's going to go like this. Because that leading coefficient's positive, you're going to go like that and like that. Okay, now we got enough to graph this. What's going to happen is it's going to go like this. It touches, so it's going to have to change direction. It's going to have to go like that, change direction, and kind of have to do something. Did I get that right, or did I miss something there? Oh, hold on. Okay, teacher did something really stupid. Okay, if the multiplicity is odd, you cross. If the multiplicity is even, you touch. Okay, well, I bailed myself out because I caught my mistake, because it didn't make any sense. Sorry about that. I should have caught that and been more careful about that. My apologies. Okay, so let me start this again. Okay, so it's odd is going to cross. Okay, now it'll make sense. So you're going to cross there, so it's going to go like this. Okay, so it's got to go like this. It goes like that, and it crosses like that. Now see what will happen is that graph will tell you everything that this sign chart says. So you're below the x-axis like that. Then you're above, then you're below, then you're above again. Okay? It wasn't matching up, so it's even multiplicity is when you touch. I don't know why I did that. Okay, does that make sense? Okay? So you can put together that graph based on what we've learned, so you don't have to go to your graphing calculator. You can put stuff in and do that graph like super fast, say. Okay? Okay, I want to do one more thing. I want to do, let's do this example 1. Let's just do one rational inequality, and then the rest of the time we can review, okay? All right, so what we're going to do with this one is, now this one is greater than 0. So what we're interested in is we're really interested in where the graph is above the x-axis. Okay, just like the last problem, I was really interested where it was below the x-axis because it's less than 0. So actually what you do on this, when you have a rational function, what you do is you just work with the numerator and set the numerator equal to 0, so that's 3. Work with the denominator. Okay, that would be x equals negative 1, and you would be undefined at x equals negative 1. Now you got to be kind of cautious about a few little things on these problems when they show up. Okay, So here's what we would end up doing with this then. When you do your sign chart, you want to use 3 and you want to use -1. Okay, and put it in order. So let's put like -1 there. And then what I like to tell students to do, I just notate it somehow. It's undefined. Just make it very clear that you know you're undefined there. Okay, then at 3, you are defined at 3, so you'd end up having that. See, what you have is you have a vertical asymptote on this problem. Okay, you have a vertical asymptote at -1. So what we're going to do is we're just going to do test points. Okay, and this one will be pretty easy. So let's take a point that's below -1, like -2, plug it into the original problem. So you would have 2 minus 3. No, -2 minus 3, sorry. So we have -2 minus 3 over -2 plus 1. So that's negative over negative. That's a positive, so that means that you're above the x-axis right there, right? Okay. Take a test point between -1 and 3. Let's take 0. You plug that into the function, you would have 0 minus 3 over 0 plus 1. That's a negative over a positive. That's a negative. So that means we're below. Okay. And then take a test point bigger than 3, like say 4. Plug it in. You'll have 4 minus 3 over 4 plus 1. That's positive over positive. So you're positive. So you're above like that. Okay. All right. So what's the answer to this problem then? What are we looking at? We're looking at greater than 0. So what are you looking at? Okay. Right where it's above. So it would be there and it would be there. So these are the two regions where you'd have your answer to your problem. Okay. I'm just going to put a little number line graph on that. So you'd be there and you would be there. That would be where the solutions of that problem lie. Okay. So in interval notation, you would just say -infinity to -1 with a parenthesis, and then union 3 infinity there. Okay. Now, one thing that happens on these problems, and we'll talk about this next week, what if that was a greater than or equal to? If that was a greater than or equal to, then you'd have a bracket there. But you wouldn't have a bracket there. Do you know why? Because it's undefined, right? Okay, good. You have to, that's the real picky detail you got to watch. So you would have bracket there, but it's still parenthesis there because you're undefined. That's why I'm putting those U's there. I tell students to do that so it jumps out at you so you don't make that mistake. Okay, and then set builder notation will go like this. We say set of x, and we would say just x is less than -1 or x is greater than 3 like that. So that's how that goes. Okay. All right, and then graphically, we're really just kind of doing what we learned how to do in the previous section tonight. So let's just go through and let's sketch a graph. Okay. If you go back to the beginning of this problem, where's the vertical asymptote? -1. X equals -1. So what we would do is you would know, okay, at -1, you would have a vertical asymptote like that. Okay. The other thing that you would know on this is you would really know that we have an x-intercept. When you do the x-intercept, remember x-intercept, you take whatever function I give you and you set that equal to 0. Now, all you're doing on that is you're really, since you're getting rid of the fraction, you're just doing x minus 3 equals 0. So that would give you x equals 3 would be your x-intercept like that, okay? And that's it. Now, let me ask you one other question on this. If you look at this, can you tell me what the horizontal asymptote is? Degree of top is 1, degree of bottom is 1. They're equal, so what does that tell you? 1 over 1. Okay, what it's called is the ratio of the leading coefficients, so your horizontal asymptote would just be y equals 1 over 1. Okay, that's what you do anytime the degrees are equal, is that's where you get that asymptote. So then you would have an asymptote going like this, then it would kind of look like this. And then based on the sign chart, well, look at the sign chart, and this would tell you how this goes. You're above the x-axis here. Okay, so if you look at the sign chart, you're above the x-axis in this region. That means you would have to go like this. Okay, you're below the x-axis from -1 to 3. That would mean this graph has to do something like that there. It has to. And then you're back above, so it would go like that. Okay, does that make any sense? I mean, you know how it behaves around asymptotes, so that's the way that's got to go. It's got to be above, approaching the asymptotes like that. It's got to be below, so it's got to go like that. It's got to be above like that. Okay, you get the same thing. So really, if you do this graphically, you would just be looking at where are you above the x-axis. Same thing. The sign chart does that for you anyway, see. Okay, all right, does that make sense? Okay. Okay, let me close this off then. That's all I'm going to do on that.